Introduction to CNC Turning Controller. This is a machine controller unit. It is an inbuilt computer of the CNC machine tools. It handles all elements of the machine tools and also gives feedback on every position of the machine tools in 3D graphical display. In this controller, we can create a program, execute the program, and operate the machine tool. It is called HMI. HMI means Human Machine Interface. What is the use of HMI? In HMI, we can observe in the axis position data, technical data, program data, and extra. It is called PPU. PPU means Panel Processing Unit. The right side of the controller, you can see the keyboard. It has all the most common character buttons. Below the keyboard, you can see the operating area navigation buttons of the controller. For the program navigation, you will use the blue arrow buttons and the select button in the middle. The 6 buttons on the right are the main operating areas of the controller. These will take you directly to the respective areas with just one button press. It is called MCP. MCP means Machine Control Panel. The Machine Control Panel on the left-hand side, you will see the emergency stop button, which you only use in an emergency. To the right, there is a number in a digital display that shows the active tool from the tool management of the controller. Below there is the mode navigation of the controller. You can use the hand wheel, jog mode, reference point mode, auto mode, single block, and AMDA mode. Further descriptions will be covered later. The darker gray buttons activate and deactivate further functions. If the lamp is active with program tests, the axes are simulated. MO1. The machine is in optional stop mode, and ROV is the dry run. It is active for rapid movement. On the right you can see 12 buttons, which are made for individual functions by the machine tool manufacturer. For example, activating and deactivating the lights. The next important keys are the direction arrows of the X and Z when you hold the middle rapid button, and the direction of the axis will move in rapid mode. Below there are 3 keys you use for moving the axes in defined length, which is 1 micron, 10 microns or 100 microns, in the handle wheel mode. Finally, there are 2 override rotary potentiometers. The first one is to influence the spindle speed, and the second one is to influence the feed rate. The buttons below on the left side to select the direction of the spindle rotation. On the right side is reset, stop, or start the active program. Next, move on to the software. We are using the Cinumeric 808D simulator. Double-click on the software. Next, click on the New and select to create a new machine configuration template, and click Next. In this tab, 3 machine templates are available, and we are selecting the turning machine, and click on Next to finish the machine template creation. Select the machine, and click on the Start. It is the interface of an 808D simulator, the same as a machine controller. We already discussed the machine controller, like HMI, PPU, MCP. After starting the simulator, we can do the first thing. Adjust the spindle override and feed override. Suppose we are not releasing the feed override, the axis cannot move. Next, move on to the reference point mode. By default, switch on the machine, this mode active. We can observe in HMI, MX1 and MZ1 axis showing a circle type symbol. That symbol means the machine is not referenced. How to reference the machine? Simply activate the reference mode and press the X plus button. After that, press the Z plus button. Now observe the symbol. That symbol indicates the machine is referenced. Next, jog mode. In this mode, we are using mainly the axis movement with soft keys and TSM options extra. Now, click on the jog mode. It is activated. Now, click on the X-axis button. Observing the display, the X-axis value is changed. Next, click on the Z-axis button, the value is also changed. Next, move on to the TSM option. That option is available on the controller display, horizontal buttons. TSM, how it works? I will show one example. Click on the TSM. The first option is the tool change option in TSM. Now controller display, the tool number is 0. I will give the 1 in this option. Next, click on the cycle start button. Now observe the controller display. The tool number is changed from 0 to 1. Next, spindle speed. I will give the spindle speed value as 500. Click the down button. Select the spindle direction. Next, click on the cycle start button and observe the display. Next, click on the reset button. Next, move on to the handle wheel mode. It is the same as jog mode, but here axis movement purpose using on the handle. That is available outside of the controller. Like this, we can rotate manually. The next mode is MDI mode. MDI means manual data input. Suppose we change the tool, spindle speed, and activated the one block program. We are using this mode. Next, auto mode. It is used for executed program running purposes. After the simulation of the program, we can execute the program and run the machine. Without activation of this mode, we cannot run the total program. I will show one example. Click on Program Manager. Select one program. Next, click on the input. This is an example program. Click on the simulation button. This is a simulation window. Now, activate the auto mode and click on Cycle Start. Now observe the simulation of the total program. Click on Reset. Next, activate the single block mode. Click on Cycle Start. Now observe the above program simulation. It is showing on one indication. If a single block is ended, SBL mode is activated. Again click on Cycle Start, the second block is activated, and stop the next block. In this mode, we are using for block by block program running purposes. Click on Reset. Next, move on to the program buttons. Program Manager. Click the Program Manager. It is used for new program creation and a list of the programs checking purpose. Next, Program. It is used for the previous program opening and edit purposes. Next, Machine. It is used for direct move on to the machine window. Offset. It is used for checking on tools list, tool offset values, WCS values, and new tool creation purposes. Alarm system. It is used for checking on the alarm list. Custom. It is used for parameter checking purposes. Before going into the program, we will discuss the types of operation, tool types, and edge position numbers on CNC turning machines. Types of operations. Facing. It is used to reduces the length of the material. Turning. It is used to reduces the diameter of the material. Profile turning. It is used to counter profiles. Grooving. For the slots creation, use a grooving operation. Threading. For the threads creation, use a threading operation. Drilling. For the holes creation, use a drilling operation. Boring or internal turning. For enlarge hole diameter, use the boring operation. Knurling. For grip holding creation, use a knurling operation. For these operations purposes, we are using single point cutting tools. Next, we will discuss tool types and edge position numbers. These are the edge position numbers based on tool turret position. In these numbers, 3 and 4 are the OD turning edge numbers. Next, 1 and 2 are the ID turning edge numbers. For mostly turning and grooving operations, we are using these edges. 5 and 7 are the axial tool edge numbers. Next, 6 and 8 are the radial tool edge numbers. For the mostly drilling operation, we are using these edges. In the turning tools, we have two types of tools. They are left hand tool and right hand tool. The left hand tool moving from right to left direction based on the direction is called the left hand tool. The right hand tool moving from left to right direction based on the direction is called the right hand tool. In OD turning and facing operations, we are using edge number 3. ID turning, we are using edge number 2. Next, move on to the software to create the new tool. The new tool creation option is available on Offset. Click on the Offset button. Next, move on to the controller display. In that display vertical keys, New Tool option is available. Click on the New Tool. Now we are selecting which type of tool we require. Turning, grooving like that. Click on Turning. In the controller display, the new tab is open. In that tab, We fill the tool location number and select the edge position number. In tool number, I will give the 4, because 1, 2, 3 is already filled. Next, select the edge number 3, based on our requirement. Next, click on OK. Next, move on to the programs. First, we will start the facing program. This is our drawing sheet. We observe the drawing sheet. In that sheet mention, reduce the 2 mm length. The length reduces we are using facing operation. This is our raw material. The length is 102 mm, and the diameter is 80 mm. It is the origin. Above the origin is x plus, and below the origin is x minus. The x-axis is called the radial axis. The right side of the origin is z plus, and the left side of the origin is z minus. The z-axis is called the axial axis. The facing length is 2 mm. In that 2 mm we can't complete in a single step. That 2 mm we can divide into 2 passes. Now each pass value is 1 mm. That is called depth of cut. Now each pass of the depth of cut value is 1 mm. This is our home position. Tool is available here. Next, start the program. G90 absolute program. It means the whole program values are single origin. G71 program data in mm. It means the program values are in mm. G95 feed in mm per revolutions. G64 continuous path on. G40 tool radius compensation cancel. Suppose we activated tool radius compensation in the previous program. That cancellation purpose uses this code. G18 ZX plane selection. It is based upon machines. Mostly in turning machines used in G18 and milling machines G17 is used. Move on to the next block. G75X0Z0. It means a return to the reference point. Next, select the tool. T01D1M06. T01 means tool number. D1 means tool offset number. M06 tool change at home position. Next, activate the spindle speed and direction. G96M03S 150 LIMS equals 1500. G96 constant cutting speed on. M03 spindle rotates in a clockwise direction. LIMS means maximum speed. Next, safety point. Before touching the material, we can hold the tool near to the workpiece. That is called the safety point, based on raw material. This is the safety point. G00X85Z5. Now the tool is moving from the home position to the safety point with rapid feed. G00 code used in the program. That time tool will move the linear in rapid feed. That's why this code is used in non-cutting areas. Next, activate the coolant on code. That is M08. The next tool is to move in the Z- direction, and X is constant, because the facing operation time, depth of cut value is taking in Z direction. Like this. That value is G01X85Z-1 and F0.15. G01 means linear in slow feed motion. This code is used in cutting areas with slow feed. F means feed rate. In this program we will give the feed value as 0.15. It means per spindle revolution, the tool will move on 0.15 mm. The next tool is to move in the X direction, like this. That value is G01X-1Z-1. Next, the tool is moving on safety point. G00X85Z5. 1 mm facing length is completed, and remaining facing length is 1 mm. Again tool is move in the Z direction. That value is G01X85Z-2 and F0.15. The next tool is to move in the X direction. That value is G01X-1Z-2. Next, the tool is returned to the safety point. G00X85Z5. Second pass is also completed. Next, stop the spindle and coolant off. That codes M05, M09. Now the tool is in safety point. The tool is moving return to the home position. That purpose we use on G75X0Z0. Next M30. It means the program end and reset. Next, move on to the software for this program simulation purpose. Click on Program Manager. Move on to the controller display. In the vertical keys, click on New. The controller display new tab is open. Next, enter the program name is facing. Click on OK. The new file is open. Enter the program in this file. For program entering purposes, we use a keyboard. Block number starts with N10, N10, G90, G71, G95, G64, G40, G18. Click on Enter. G75, X0, Z0. Click on Enter. T01, D1, M06. Click on Enter. G96, M03, S150, LIMS equals 1500. Click on Enter. G00, X85, Z5. Click on Enter. M08. Click on Enter. G01, X85, Z-1, F0.15. Click on Enter. G01, X-1, Z-1. Click on Enter. G00, X85, Z5. Click on Enter. G01, X85, Z-2, F0.15. Click on Enter. G01, X-1, Z-2. Click on Enter. G00, X85, Z5. Click on Enter. M09, M05. Click on Enter. G75, X0, Z0. Click on Enter. M30. After the program enters. Next, click on the simulation key. That key is available on horizontal keys. Click on Simulation. Activate the auto mode. Next, click on Cycle Start. Now observe the controller display.